Once we rotate it, we can find a small line has been drawn. That means from here to this face, we have to make the facing operation. This total instrument is called the marking gauge. Now we can see the opposite face of the job is being attached with the chalk, and the marking is being done till that we have to face it. The facing operation will be same. Now we have to face it as the thickness may be a little bit high. We have to do it in 2 or 3 passes. So the touching point is being taken, it has been taken back, a little bit depth is been given. Now you can see again the facing operation is being repeated on the other side. Next thing, again the facing and centering operation is being repeated on the other side. The drill bit is again fixed inside the tailstock. It is brought close. Then the nut which you have seen in the previous operation, it is being tightened, and then the centering operation is going to be followed. This is called a revolving center. You can see it is a conical in shape and the center revolves. Now it will be fixed inside the tailstock. Once it has been fixed in the tailstock, then we will go to the next operation, which is called turning. Now you can see for turning, we have to remove the material over this face. So the job will be kept in a hanging position. This revolving center is being attached with the centering of the job. This is because it will give a support to the job while in hanging position, so that the job doesn't rotate eccentric while the material will be cut. Now we are ready to do the turning operation. You can see the tool post is being made straight and it will touch this periphery. There we get the reference point, and from there we have to move 3 mm in diameter, because the diameter of the job is 25 and we have to reduce it to 22. So 3 mm of the diameter will be removed in 2 or 3 passes. So we are ready to do the turning operation. Now we are going to see the touching point of the tool with the job. So the tool has touched the job, we take it outside. So once the touching point is being found, here we take the 00 marking, which is the reference. Now there is a scale over here. We rotate the scale without disturbing this handle. The scale is being rotated and being touched to 00. Okay, so there means the tool is right now at a position where it can make a diameter of 25, because this is 25. The tool is at a point, if it's moved to and fro, it will be touching the 25 diameter. So it can make 25. Now, once it has been set to 00, we move it clockwise 10 division. The tool post moves 0.5 mm forward. Hence, it reduces the diameter by 1 mm. So the least count of this scale is 0.1 mm per division in reducing the diameter, and 0.05 mm per division to reduce the radius. Now we are going to start the turning operation. it is used to reduce the diameter. You can slowly see a silver cylindrical surface is going to emerge while the tool is going past the job piece. 1 mm is being shortened. That means from 25, right now the diameter which is being evolved is 24 mm. Now we can see the final cut after 2 passes. This is the third pass. We are reducing the diameter by 1 mm. So 25 to 24, then to 23. Now we are going to 22. We are rotating the wheel over here very slowly, so that the wheel is being rotated very slowly, so that the tool goes very slowly over the surface to get a finished surface as 22. The diameter which is evolving is at 22. Now we stop the turning operation. Now we can see at 22 we have turned more than 50 mm. Now from this part to this we have to mark 50. For this reason we take a scale. See, the 10, 20, 30, 40, 50, 60 have been given. This is called an engineering scale. Here this end resembles at 0. So to mark 50, what we do, we put it on a plane surface. Then we put this caliper and see whether one end is at 0, another it has 50 or not. So once it has been 50, we have to lock it. Then slowly we make a marking on this face. So right now we are going to mark 50 on the job. The inside caliper, the one end should be at this end of the job, another end should be at the tip of the job. The tip of the, we have marked a chalk mark over here, so that when the tip of the job make an engrave or an impression on this job, it can make a silver lining. So we have marked a chalk for the marking system. We make the tool move close to the job and we place the tool head at one end of this inside caliper. Once it has been set, now we make a marking by rotating the cross slide and just touching the tool with the job. You can see this is 50. 70. Now, once the 50 has been marked, we have to mark it at 50 plus 20, that is at 70 also. For that, we again take the scale and see, it is not at 70. We slowly, by revolving the screw, we get it to 70. Now it has reached 70. The same operation will be repeated again by placing the inside caliper over here, the another face of the caliper over the tool, and we have to mark it. Now we are marking at 70. You can see a silver line is being formed which marks the 70. Now after both the marking which is given here, we have to make chamfering operation at the end. It is 45 degree, 2 into 45 degree. That means once it touch over this diameter which is formed after the chamfering operation should be 20. This maximum diameter is 22. So 2 reduce 22 from this 22 will be 20, and the angle by which the chamfering will be done is 45. So you can see the tool is right now rotated by loosening the screw. Actually this face has to be 45 degree while touching this edge, so that the chamfering can be done. So 2 mm has been reduced, you can see the chamfering. Next, we will reverse the whole job rotation. The next operation, we will reverse the job orientation. Now we can see by loosening this, we are taking out the job and we will fix it reverse. Now, again the revolving center is being used to support the job and the operation will be done on this face. Now, as we have reversed the job, now this is under the chuck grip and this part is on which we are going to operate. So here the next diameter which is being formed has to be 12.7. Hence the diameter from 25 raw jaw diameter we have to reduce it to 12.7. That means 12.3 mm of diameter has to be removed. That means if you calculate on that cross slide scale, you have to rotate 123 division part by part so that we can achieve. Now again the 0 marking is being taken over here. Once it will be taken, it will be done in 5 or 6 passes. Suppose we take 6 passes, we will use 20 mm or 25 mm at a time and we will move 4 passes and another 23 mm last pass which will give up to 123 division. Now we can see the turning operation has been started. Here the diameter which is going to form will be much lower than 22. So this is also called the step turning process. Once the big diameter, the next diameter is formed. Here we are starting step turning and the diameter that we are going to achieve is 12.7 mm. Now we can see a small diameter is being formed after the big one. The small is 12.7 and this is the final cut which is done with a small depth of cut and slowly rotating the wheel. This is done up to that 70 mark which has been marked from that side. Chamfering of this end has to be done. See, the operation is going over here. The chamfering is done. The chamfering is done. After this, we will go for the operation which is called grooving. See this collar which is having a 10 diameter. This grooving will be done 30 mm from this end. 30 mm from this end with a width of 5. The grooving operation will be done to a diameter of 10. Now for the grooving operation, see this is the turning tool. We have the groove tool fixed on this end. So we have to take this groove tool over there. For that we make this screw loose and we rotate the tool post. This is the groove tool which is coming into the line of action. This groove tool has a depth of 2 mm. It is going to cut perpendicularly straight over in and it is having a width of 2 mm. The width of the groove is 5. So we have to go twice or 2.5 times of the tool this way or round way to get the groove. Now while the turning operation was done, you can see at this end the surface is little bit taper. We use the groove tool to make this tapered surface perpendicular or straight. Once we made it straight, then we will go inside the job diameter of 12.7 to get it to 10. The surface which is coming out is straight or perpendicular. Diameter of 12.7. From here we have to go to 10. That means we have to reduce 27 division. So 27 division into 0.1 gives us 2.7 division. That is the reduction in diameter required. small incremental depth of cut of 5 division, that is 0.5 mm reduction of diameter is being given, and the tool is moved to and fro. Like that, we have to go to 27. You can see the corner has started forming. The corner has started forming. Slowly we will go inside and we will move the tool to and fro. We can see the collar is being formed. Now the next step is to make the taper turning on this 20 mm length with an angle of 10 degree. So for that reason, we have to again come to this tool post and we have to swivel the tool and we have to get the turning tool again in the line of action. Once it has been put to the line of action, on this tool post, see there is a nut over here. A similar nut is just opposite to this. We have opened this and we have rotated the tool post to 10 degree. You can see 0 and this marking is at 10 degree. So this angle which is the tool post forming right now is 10 degree. The whole thing is to be controlled by this compound slide. We can see if we rotate the compound slide through this handle, the tool post revolves or moves on a 10 degree angular form with the base. Hence, by rotating this compound slide and engaging the tool over the job, we can get a 10 degree cut. See, we have to actually get the taper from this line to this line, but we will start somewhere down here because as the tool will go in a triangular form towards this lower surface, at this point the chip removal will be much higher. To reduce that chip load at the last point, we will be doing it part by part, and at last we have to touch this line which is the 50 line from that end, and we have to go slowly downward to get the taper. You can see the compound slide is being controlled from this end and the tool is moving with the 10 degree axis of the lead axis. Now we can see the final pass of the taper turning has started. Once we finish the taper turning, the last and the important operation what we are going to see is half-inch BSW thread on the diameter 12.7. We have made it 12.7 means half-inch BS BSW thread. Half inch means half of an inch. It is 12.7, 25.4 by 2. So that is the half inch diameter. And BSW thread, you can see a finished product which we have already made it earlier. So this is the thread which is going to be formed. Now there is a thing, the number of teeth, the number of thread that is going to be formed in an inch in half inch BSW thread is 12. So 1 by 12 is the pitch of this thread. Here you can see the thread, it has a peak form and it has a lower form. It is like a triangular in shape. So the depth up to which we have to make an impression comes with a formula of 0.6403 into pitch, which is 1 by 12 into 25.4, because it is done on a millimeter and half inch. So from inch to millimeter we are converting, that's why we are using 25.4. We are multiplying the factor, which comes 1.35. That means the top to this bottom should be 1.35. So here a thread chart has been given. Actually the machine has combination of gears and other things to make threads. Here the combinations are being given. As you can see, the thread per inch for half inch BSW thread is 12. Here 12 is at the lever B. So we can see the lever has to be at B. So we can see the lever is at B and the hole is 7th hole. While putting in the lever B, it has to be the 7th hole. You can see the number of holes are being formed here. 1, 2, 3, 4, 5, 6, 7. See here the pin has been attached to the 7th hole. Now, so the tumbler lever is being attached to the 7th hole. While doing that, now we come to the main important thing, which is called the half nut mechanism. Actually, the thread is formed. Actually, the tool moves at a certain distance per rotation of the job, and this has been controlled by this feed rod and the lead screw. Here, the half nut mechanism is there. While we engage the half nut mechanism by this lever, the half nut engages over the lead screw. We are going to see the half nut mechanism. We come to see the half nut mechanism. Actually, in this lathe, we are seeing from this end. The half nut is just opposite to this apron. So this is called the half nut. You can see two cylindrical surfaces are being aparted. Here, the threads are being formed. Suppose this is the lead screw. While we engage the half nut system, the two jaws, the two half cylinder jaws actually engages on the lead screw. We move the half nut lever upward. You can see it has engaged. Whilst we move it down, it is disengaging. Again, we are moving it up, the engagement is done, and while we are doing it down, the disengagement starts. Actually, this feed rod rotates at a particular or a synchronized speed. Whilst we engage the half nut mechanism, with the rotation of this, here some threads are found which actually moves this whole carriage to and fro with a synchronous speed with the chuck to help to form the threads. We have made the machine ready to make the threading operation. The first major change we can see is the rotation of the job. It is much slower than the previous operations. Here the operation is very delicate, so we have to do it in a very slow speed. Once it has been seen, you can see the lead screw has started rotating. Now, if we engage the half nut, you can see the tool post moves or the carriage is moving. You need to disengage the half nut, please disengage. You see the lead screw is moving, the carriage is not moving. So this is the function of the half nut mechanism while the lead cutting the thread. So we are starting the threading operation. We have taken the touching point, a little bit of depth of cut is being done. 1.35 is the total depth of cut. We will be doing it in at least 2 passes, minimum 2 passes, maximum 4 passes. So we are using it. We are giving 0.6 mm at a time and we are starting the threading operation. You can see the threading has started. The chip is being removed and the impression is coming out. You can see very clearly. Once it has been done, it is withdrawn. The half nut mechanism is being disengaged. Again, from 0.6 to 0.1, the total depth of cut is being given. Again, the same operation is going to be repeated. The half nut mechanism is engaged. You can see the tool is moving on the same path and creating the same impression with a little bit more depth of cut. The final pass is being done right now. The depth of cut is being given. The half nut mechanism is being engaged. Once it has been cut, withdraw. Now we can see the thread has been done. The total job which has been given has been completed. Now we stop the machine and we will take out the job. Now we can see the job diagram over here and the finished job is being done over here. The raw job diameter which was provided to you is being transferred to the finished job. You can see the threads over here. The threads look like this. This is the groove, taper turning, chamfering, facing and centering in both the ends. So the whole job is being done. Good luck to you all.
So any questions?
Yes, sir.
Yeah.
Start.
Sir, how did we decided the pitch of the length?
Yeah.
So how did we decided the pitch of the length? Pitch.
That is already been mentioned. That's why it has been mentioned that half inch BSW thread. So that in that case the pitch is already fixed.
Okay.
Sir,
Yes.
sir, relation between pitch and depth are fixed, sir.
Yes. Relation between pitch and depth is fixed for a particular thread.
WS. Okay, sir. Okay.
Excuse me.
So will we get
Sir,
this video and PowerPoint in a mail?
Yeah, you will get this video link and PowerPoint in your in this particular section only. You will get it later. It will be uploaded.
Okay,
Thank
sir.
you, sir.
hello, sir.
Yes.
Sir, how did that formula come up? 1/3 into cot 27 degree, something like the PowerPoint. The slides you showed.
Yes, there was the formula. So
Sir,
okay.
1/3 multiplied by cot 27. Where did that?
Yes, that is the depth of the formula. Wait just a minute. Yes, this is the depth formula of the thread profile. So if you this is just for your knowledge. So if you go depth into this profile thread, and there are different threading operations. So I have already mentioned this is BSW thread. There are other threads like Acme thread, isometric thread, and square thread. But this is several different operations. So when you go threads in study details, you will study in details. So then only you will know understand this formula.
Okay, sir. Thank you, sir.
Okay.
Sir, can we make cuboidal structures with this lathe?
Cuboidal structure. So actually, in that case, so okay, let me just see.
This is the taking the required head of the machine.
What you can do is you fix the cuboidal structure and you can do facing operations like this. But if you want to do for turning operations, so that will be very difficult in case of lathe. So here you can see this is these things needs to be mentioned.
And the center taper turning, you can see first the job diameter fine. How job length is, and now
Just see his operation. This is called the key, chuck key. So it is this key is used for the chuck operation. So this is called the chuck key. This is called the three-jaw self-centered chuck. So there are three holes are like this. So he is putting chuck key in one hole. So if you put chuck key in one hole and rotate, so all